Okay, so this is the problem we did in class when I introduced method of sealed bids. To remind everybody, method of sealed bids falls under the category of if we are studying voting, apportionment, and other such decision making mathematical models. Okay, and it's a really big topic. But I particularly like the method of sealed bids as a way of dividing things, because unlike almost all the other topics in this area, in this case you actually succeed in fairness. And so fairness is a pretty cool thing. Fairness is really hard to achieve, and in most cases it's usually impossible. In this case it's actually possible. So this is sort of, to me, the most optimistic thing to talk about. Okay, so in the method of sealed bids, you have to have certain conditions, otherwise you don't have the option for fairness. The important conditions are that the players who wish to divide a pile of objects fairly they have cash to make this job easier. And let's just assume for the moment that they're at relatively the same wealth station in life. It doesn't work if you have a very rich person and a very poor person playing. They have to have enough cash that if they wished, they could just outright buy all the objects that are sitting there to be divided. So it works fine if you have, a couple toys and brothers and sisters who have some spending money. It works perfectly fine if you have really wealthy people and they're trying to divide cars. But if you have like brother and sister trying to divide cars, this isn't going to work. So you have to have enough wealth in your immediate liquid environment that the objects are really not that big of a deal to you. Okay, so you've got those conditions, and then you can go ahead and fairly divide. Okay, so let me just say, let's say we have, this is the example we just came up with randomly in class. We have Janice, Marvin, and Skylar splitting up a bike, a framed print, a typewriter, a Rubik's Cube, and an LP record player. So I'm going to pause so that I can put this on the screen for you. Okay, so here's the 3 players and the 5 objects and how each player values each object. And one of the things you can notice is that if somebody doesn't want an object at all, they're welcome to bid $0 for it. That means they're absolutely not going to get that object. It's you can ensure you get no objects by bidding 0 on everything. So one of the things is that we want to know what's fair to each player. And let me just start out by saying there's more than one way to fairly divide the objects, and there will be cash also floating around. There's more than one fair way to do this. However, this particular method is very formulaic, and the only time you really need to make a decision is if 2 people ask for the same object at the same maximal price. So for example, if these Janice and Skylar had each said the Rubik's Cube was worth $15, then you could choose whether to give the Rubik's Cube to Janice or Skylar. But because Janice and Skylar both think it's $5, but Marvin thinks it's worth $10, Marvin's going to be the one who ends up getting that object. Okay? So once we know what everybody thinks about everything, we simply give each object to the highest bidder. So we start by giving Skylar the bike and the framed print, and she's actually, oops, I'm sorry. She's only going to get the framed print and the typewriter. Oh, she's going to get the LP player. Marvin's going to get the bike, and Marvin's going to get the Rubik's Cube. Poor Janice is going to get nothing, okay? But Janice is going to end up with money, because that's the way this particular method works. Let's look at the totals. Let's see what everybody thought everything was worth. Janice thinks everything's worth $105. Marvin thinks everything's worth $130, and Skylar thinks everything's worth $300. And since there's 3 people playing, so total divided by N means what each person's fair portion is. So Janice needs to get $35 back. Marvin needs $43.33, so $43.33 is what Marvin thinks he's owed, and Skylar thinks she's owed $100. And you will see that, except in very strange circumstances, everybody's going to end up with more than they think is their fair share. And this is the coolest part about this, is we're taking advantage of the fact that different people value things at different levels. If everybody valued everything exactly the same, then everybody will still get their fair share, but they won't get more than their fair share. But as long as there's somebody valuing something different than somebody else, everybody will be happy. Everybody will think they're getting the best deal. Okay, so here's what we do. We figure out how much everybody thinks they deserve, and we'll figure out how much they got and find out what the difference is. If you got more than you deserve, you have to put money into the pot or into the kitty or whatever you call it. So let's see how much Skylar got. Value of objects received. Okay, so the value of the objects received is $0 for Janice. Marvin is $60, and Skylar is $260. Okay, so she received $260 worth of objects, but she only deserves $100. So Skylar is going to pay $160. So I'm going to write it this way: 260 minus 100. So think of it as if she's got a $100 coupon. So she pays $160 into the pot. Okay, into the common zone. Okay, and what about Marvin? Marvin has to pay because he got $60 minus 43.33. So what's 60 minus 43.33? 60 minus 43.33, and he gets to pay $16.67 into the pot. Okay, and then what happens is there's currently 76.67 currently in the pot. So all the people who paid have paid, but now guess what? We owe Janice $35. Janice is owed $35 from the pot. And so she gets the $35, leaving how much? So what do we have? We have minus, so we have 176. So we had the 1667 plus 160, right? We have this 176.67 minus the amount we have to give Janice, so she gets her fair share, leaving 141.67 in the pot. And you say, okay, so if they're really, really generous rich people, maybe what they'll do is they'll do this method of sealed bids, and they'll take this leftover kitty and they will just donate it to a good cause. That would be cool. But that's not the way the method works, but you can totally do that. What we're going to do is we divide the leftover pot by, guess what? By n, in this case by 3, and we give that money back to everybody. So divide by 3 equals $47.22 per player. So what each player gets is $47.22 more than they think is their fair share. You see, this way, first of all, everybody gets their fair share, and then there's $47.22 left over per player. And the last thing you need to do is what's called the final cash outlays, because, you know, we can just do this. If it's only 3 players, we can sit there and count out the money, but that's really dorky. I mean, we have arithmetic for a reason. And so what we're going to do is we're going to figure out how much each person has to pay in, right? So Janice pays nothing. What's the final cash outlays? So what do we say? We're going to just say final cash outlays and so what this means is the person who receives all these bids does all this work behind the scenes and then comes back to Janice, Marvin, and Skylar and says, okay, Marvin, you get the bike and the Rubik's Cube. Skylar, you get the print, the typewriter, and the LP player. Janice, you get this much money from Marvin and Skylar, and you just do it like that, right? Oh, we got one more thing we got to do. Let's see. We have to figure out, yeah, we have to do all this arithmetic. Okay, so the grid tells you who gets what, but the final cash outlays, what does Janice get? Janice got the $35 she thought she was owed plus the $47.22 per player. So she gets that plus, what did she say she was owed? $35. Okay, plus 35. Whoops. Oh wait, 82.22. I guess my calculator does that. 82.22 owed to her by the other two players, so it better add up. But what's going to happen is Skylar owes the most initially. Skylar is the one who put 160 into the pot, but this is going to get subtracted because she owes 160. That's how much she thinks she's going to have to pay, but she gets like a coupon back for $47.22. So it's 160 for her, 160 minus $47.22. And then you get 111.78. What? I get 112. 112.78. Okay, this is Skylar amount owed. And then who else do we have? We have Marvin. The question is Marvin going to pay or is Marvin going to receive? Well, clearly if Skylar is paying 112, Janice isn't receiving all that, so Marvin's going to be the one receiving the extra. But let's first make sure that works. Marvin originally thought he had to pay $16.67. But think of it the other way. If Marvin got $47.22 and then owes $16.67, then we just subtract it the other way. We can say $47.22 minus $16.67, and then we get $30.55. So $30.55 owed to him. Okay? So we did all this arithmetic, and this is what the treasurer comes back and says. These are the final cash outlays. Janice and Marvin get money from Skylar. Now let's just add these up and make sure they add up. If they're off by a penny, it's okay because that could be round off, but it shouldn't be off by more than 1 or 2 cents. So you take all your calculations to the penny, and if you're off by more than 2 cents, then redo that. So let's make sure this works out. The Marvin amount is $30.55 plus the Janice amount is $82.22. This should add up to the Skylar amount. See, it's off by a penny. That's okay. It's all right to be off by 1 or 2 pennies. That's good enough. Okay? And then you can say, well, whatever. You can just adjust this or not. I don't care if you adjust it. Round off 1 cent is okay. Alright, and that's how that works. You have to just have a grid with the circles, tell who gets what, and the final cash outlays should add up. Alright, so just make sure when you do this, your final cash outlays, whoever is owed money, has to add up. The pluses and the minuses have to add up. In the final analysis, each player either puts money in the pot or takes money out of the pot. And all those pluses have to add up to all those minuses. If that works and it seems plausible, then the answer is probably right. Okay, hope you enjoy that.